Hey guys, welcome to another video. So today, another question from the nice question series. Today's question comes from the advanced syllabus from the Kalara 2024 trial paper. It's a nice question, and as an actuary by trade, this question really touches on what I've been trying to tell my students. I've always wanted a question like this in a past paper. It's to do with annuities. It's the way annuities are supposed to be done, like a present value concept as opposed to future value. Now, if you haven't seen those videos that I've done on financial maths where I do annuities, please have a look at that because this one actually applies that theory in a 5-mark question. So let's get, oh, actually, before I dive in, if you haven't already done so, please like the video, subscribe to the channel, and tell your friends. All right, now let's dive right into the Kalara question. So 5 marks, 3 marks and 2 marks for part A, part B. Let's have a look. So, all right. When it visits a bank and makes a single deposit of Q, right? The annual interest rate is 3.5%. Perfect. Now, so she makes a single deposit of Q, and then she goes, she wishes to withdraw $8,000 at the end of each year, right, for a period of N years. Show that the minimum value of Q is this, right? And then part B, hence or otherwise, find the minimum value of Q that would permit Melinda to withdraw annual amounts of $8,000 indefinitely, right? So in actuarial talk, right, in the financial world, this is called an annuity, right? In fact, technical term is fixed term annuity, right? Because it goes for n years. Any annuity that goes indefinitely is called a perpetuity, right? Perpetuity. Now, I've not seen textbooks really touch on this notion of perpetuity, so it's a good one. And the mathematics behind it is quite neat. So actually a really nice answer. So now the first one. There's so many ways that your teacher want to do this. I've seen algebra, like I've just seen working out in lines and, just basically using similar to compound interest, etc. I like to do this by a diagram because it's nice and visual, right? So if your teacher doesn't do this by a diagram, maybe show them, right? Because the diagram way of seeing this question is actually quite neat. So let me show you. So as always, so once again, if you haven't seen the video on where I am introduce this diagram method, please look at it because it's good that we are now applying it to like a real world question, right? So times 0, 1, 2. Now this is n minus 1, and n minus 2, right? All right. So what this question is, and the notion of minimum is this, right? They can put like Melinda can put in like $1 billion and withdraw $8,000 each year, right? But that's not the point. She wants to know, we want to know what's the minimum value she can invest so that she can withdraw $8,000 over N years, right? So basically, you just, I'll show you how to do it, right? It's pretty straightforward. So I want to show you two things. One, she puts in Q dollars, right? At the very start of things, right? She puts in Q dollars. But then with those Q dollars, she is able to withdraw $8,000 at the end of every year, right? $8,000 at the end of every year. Yeah, all the way to the end, right? Now, there's two ways to do this. So I've seen in actually the solutions for this Clara past paper, the teacher basically does this, right? The teacher goes and brings forward all these $8,000 payments into the future because at school they're very comfortable with compounding, right? That's there already. So they bring everything to the future, and then they basically equate that to, they make it equal to bringing Q all the way to the future as well, right? So the final pink number equals to the sum of all the greens, and then they equate it, and that makes sense. Now, I'm going to show you a cooler way, right? If your teacher hasn't done this, this is the cooler way. We're going to bring everything to the present, right? Because at the present, Q is there, right? At time 0, Q is there. And for each one of these, we're going to reverse compound. And the word they use in the financial industry is discounting, right? We're going to discount all that $8,000 to the present. So for example, this first one here goes 8,000 divided by interest rate, right? This one here goes 8,000. oh, sorry, let me bring that arrow all the way back. So bring it back to times 0, right? $8,000 divided by 1.035 squared. Yeah, because it's 2 months of reverse compounding, right? Or discounting, right? That's what we do. So if I look at the last term there, right, that's going to be brought back 8,000, 1.035 to the power of n, right? Yeah, bring it all back. Now, the sum of all these blue terms is equal to my pink, right? It just makes a cleaner piece of algebra. And if you look at what you have to prove, right, that's what you have to prove, right? So you go, now, therefore, Q equals to 8,000 first year of compounding, 8,000 second year of compounding or reverse compounding, plus the last year, yeah, of reverse compounding. Now, admittedly, in this question, right, it's 3 marks. And I just did it in one line based on a diagram. Now, if your teacher won't accept this diagram, let's do it that way, right? So we're going to basically bring forward and do present. So you can either do, they call this present value, right? Oops, present value, right? Your teacher, obviously, for 3 marks, wants you to do future value, which is longer, and but it's uses compound interest, and that's what they're comfortable with. All right, let's try to do that. So if I did future value, right, this Q gets compounded 1.035 to the power of n. Right, mathematically, it should be the same, right? If I bring forward all of these green payments, so that 8,000 gets, now it's starting 1 year at the end of the first year, so only gets like 1.035 n minus 1. Right, that one gets 1.035 n minus 2, etc., etc. And the last payment there is just 8,000. There's no compounding, right? Because they basically, is it withdraw? Yeah, she withdraws at the end of the last year, which is no compounding. And this one here, maybe 8,000, 1.035. Yeah. Now, so the pink is supposed to equal to the sum of all the greens, right? So equally, using that future value equation, right, you can say Q times 1.035 power of n equals to 8,000. So the sum of all the greens, right? 1.035 n minus 1, 8,000, 1.035 n minus 2 plus, I'll just put the last one, 8,000. And you just divide the 1.0, this guy over, right, to each term. So I'm, like, you know what I'm going to do? I'm going to get lazy and just copy this. And just divide each term. 0.035 power n. 1.035 power n. And then, of course, the algebra holds, right? This guy here cancels out and you get the first one. 35. The second one. Oops, downstairs. 35 squared. And the last one, 1.035 n, which is the same. So what am I trying to say? It doesn't matter whether you use the present value concept or the future value concept, you should get an equal result. Now, just to be clear, they say minimum amount because if you set Q equal to the stream of payments, it's a minimum amount. Theoretically, you can hold Q plus $1 billion, right, and still be able to draw down 8,000, but they want the minimum. That's the minimum. Is that okay? Guys, that's part A, right? So I'll do it up here. Oh, sorry, I'll leave that one down there. So, but I'll put this one over here, right? So that's the formal answer that they wanted in the homework. Oh, sorry, the homework in the trial paper solutions. Yeah, I'm not sure. Like, it's fine, right? It's not the fastest, right? Using present value gets that much faster. Now, that's part A, and that's 3 marks. Yeah, part B. So they want to ask, what if they wanted to withdraw this amount forever, indefinitely, in perpetuity, right? Here's what you do. basically find an expression for this in terms of the sum of a GP, right? In this case, if this was sum of a GP, right? So just be absolutely clear. This was a GP, right? You got A is 8,000, 1.035. R is, now it's a fraction, right? So 1 over 0. Also 1.035, and N is, well, there's N payments, right? Yeah, N is N, right? So sum of GP, therefore Q, right, which is the sum of the GP, equals to A. Now, because this ratio R is going to be less than 1, we're going to use the other, so the reverse of the one we normally use for compound interest, right? 0.035 power of N all over 1 minus 0.35. Yeah. Now, let me clean this formula up because I want to show you the formula before I do it to perpetuity, right? Do it indefinitely. Because the formula actually cleans up too badly without the perpetuity cut part. So sorry, split the top. Actually, no. You know what? Leave it like this. Smart. So just go 1.035 power of N. And on the bottom, common denominator, right? So all I want you to do is downstairs here, just common denominator that bit, right? And you get 1.035, 1.035 minus 1. And then you would see that this cancels out with this, right? Because when you take it upstairs, and we can simplify this to be just 0.8,000 divided by 0.035, right? And then in brackets 1 minus. Okay. Now, great. That's the value of Q. I want this value of Q when I make 8,000 payments indefinitely. What's that mean? So when it goes indefinitely, means that N goes to infinity. Now, this is important, right? Because in this expression, when N goes to infinity, right, any fraction as such, as N goes to infinity, any fraction that has a number downstairs that's bigger than 1, right, with a power of N, right, the bottom there will go to infinity. 1 divided by infinity goes to 0. Yeah. So this whole thing goes to 0. So what's left? This is left. Yeah. 1 times this is left. So my answer on my calculator is quite simply 8,000 over 0.035. And if you punch it on the calculator, I think you get 228,571.43. That's nice. Yeah, the perpetuity formula, right? For those that are keen, right? Perpetuity formula is whatever periodic payment you make divided by R, right? It's such a clean formula. Yeah, goes on forever. Like basically, so another context for this question now. If you go to nexteducation.com.au, you can download some past papers of mine, right? The past, I think in the 2020 past paper, I did a perpetuity formula. One of the common contexts for this, right, is that, for example, universities want to set up a scholarship that pays, $20,000 every year forever. So how much money do they need to invest now into a fund so that they can fund this scholarship, right? Common context. This one here draws down 8,000 forever. The perpetuity formula, very simple, but nice question. Guys, hopefully that was okay. So the way that I look at financial maths when it comes to annuities, right, is basically you can have two ways to do it. You can either future value it, right, or you present value it, right? Personally, as an actuary, we always talk about present value, right? It's just the faster way of looking at things, right, that happen in the future. And if you want to compare it to a current value, in this case, the current value is Q. Yeah, we don't like to bring things into the future because it gets more complicated. You're compounding something that you don't need to in the pink, right? Bring it back to the present, cleaner. Guys, Hopefully that was okay. If you like that video, so if you like the concept, like the video, subscribe to the channel and tell your friends. Thank you very much. I'll see you at the next video.